Okay, well, I hope y'all enjoyed my little picture because you rock and you rule I think is cute. But so today we're going to talk about graphing solutions to linear inequalities, and then graphing the solution set, what that is, and then interpreting linear inequalities. It's kind of stuff we've already done. We're going to add on to it from what we did on Monday and last Friday. Remember, like when we graphed lines, if they intersected, that's where the solution were true. They never ever intersected, they were parallel, there was no solution. And then whenever they were the same line, it was infinite. So it's kind of similar to that. Now we're just going to look at them with inequalities and what that means. Same kind of concepts though. So look at this first one. An inequality in two variables has the same form as a linear equation, but uses an inequality symbol. So the only difference is you'll see an inequality symbol. And the solution to an inequality in two variables is all of your ordered pairs. So x comma y is just what an ordered pair is that make the inequality true. So if they give you ordered pairs and they give you inequalities, you can plug in your x and your y and solve and see, is this a true mathematical statement? Kind of like what we did with equations. When you're graphing inequalities, which is a lot of what your math Excel is going to consist of, if it's greater than or equal to or less than or equal to, so if there's an equal to sign at all, it's going to be a solid line, which means you're going to include all the points on that line. When it's solid, that means you'll include it. If there's no equal to, so it's just greater than or less than, there's going to be a dashed line or dotted line, whichever word you prefer. And then not only are the parts on the line, so when we talked about linear equations, the line were where my equations were true, but for inequalities, we're going to shade certain areas. And you're going to see what we're talking about as we move on. But if it's less than or equal to, so if it's just less than at all, you're going to shade below the line. If it's greater than or it's greater than equal to, you're going to shade above. Once you know those four things, it's really, really easy to graph inequalities. And then when you're in doubt, you can just pick or test a point to see if it makes the inequality true, because that's what we want to figure out. Is it really true? Is it a true mathematical statement when we solve and plug in the x and y? Can I scroll down? Okay, so let's look at an example. Look at the first one, letter A. What's the solution of the inequality y is less than or equal to x minus 1? So right off the bat, I want to just answer two questions. Is it going to be solid or dashed, and is it going to be shaded above or below? So looking at this one, what do you think it's going to be? Solid or dashed line? Good, a solid line because it's equal to. Is it going to be shaded above or below? Good, because it's less than. Awesome. So now that we pointed that out, it's really easy to do this. So their first step is they want you to graph the boundary line. And the boundary line is just, the y equals mx plus b. So it's basically taking away the inequality and putting an equal sign. And we can graph this line really easily, right? Yeah, so what's my y-intercept of y equals x minus 1? Perfect. So I'm going to start at -1. And what's my slope? Up 1 to the right 1, yes. There's an understood 1 in front of the x. And you could keep doing this. So now we know it's a solid line. So we're going to take it and draw a line through this, and it's just going to be solid. If it were dashed, if it were just less than, it would be a dashed line. So now that we drew our line or graphed our line, they want us to shade in the area where the y values are less than x minus 1. So looking at the graph, you just simply look and you say, where is it less than in the graph? Where's it below? And it's all this area. So you're going to shade all of this area. If you have like highlighters or color pens or whatever, pencils, crayons, whatever you like, you might want to use those for this lesson, but you don't have to do it. Just if some of y'all bring that stuff and you like to. So this solid line, what we just talked about, this solid line indicates that all the points on the line are part of my solution because it's solid. If it were dashed, the points on the line would not be part of my solution. So my solution for this example is all the points on the line, and it's everything we shaded, everything that's in purple up there. All those order pairs that lie on the line or under it would be true for this equation. Does that make sense? Good. Can I scroll down and do the second one? Are we good? I'm good. Okay. So what's the solution of the inequality y is greater than x minus 1? So what are we going to do? Graph it just like we did the other one. What's my y-intercept of this one? -1, good. And what's my slope? Remember, it's just like, yeah, it's just 1. There's an understood 1. It's just like writing y is equal to x minus 1. So you're going to go up 1 to the right 1. But let's answer those two questions. Is it going to be a solid or dashed line? Good, because there's no equal to. And then am I going to shade above or below? Above, good, because it's greater than, right? So it's going to be a dashed line. So it's going to look something like this. And then if I shade above, it's going to be all of this area. I just did that. So because you can continue to do the slope forever, but I just did it to help me draw my line. It's not a stupid question at all. So this dashed line, unlike our solid line, this dashed line indicates that all the points on the line, what do you think, are part of my solution or are not? They're not. Only the area that's shaded now. The dashed line means we don't include it. So the only order pairs that would make the statement true is all that's blue, that's shaded in the blue. But I can't include my line. We're only going to do this one, try it, and it's on page 88. And really all I want you to answer is it solid or dash? Is it above or below? And then what's my y-intercept and what's my slope? That's all we're going to answer for these two. So go ahead and work on that for a few seconds, and I'll write what you're going to answer. Type of line. where to shade and y-intercept and slope. So what type of line will the first one be? Dashed or dotted? Perfect. And so does that mean we'll include those order pairs or we won't? They're not part of my solution or they are? They're not. Good. Where are we going to shade? Above or below? Good. And then what's my y-intercept? And what's my slope? -3. But if you were graphing it, -3/1, right? Great. Okay, what about the second one? What kind of line? Perfect. So does that mean we include the order pairs on my line as part of my solution or no?
Yes.
We do. Good. And then where are we going to shade? Above or below? And then what's my y-intercept? Good. And what's my slope? Yeah, it just so happens to be the same thing. Awesome. Just wanted to make sure y'all would look at the inequality and answer those questions. So good job. So this is probably the hardest example we're going to do, and it's really not that bad. So it's just probably the most difficult one. This will be number 9 in Math Excel. On the first Math Excel, there's 2, and the first one has like 9, I think, and the second one's 5. So this will be your first on the first one, and it's number 9. So you're going to want to do exactly what we're doing here, okay? So it says the Science Club sells t-shirts and keychains to raise money. How many t-shirts and keychains could they sell to meet or exceed their goal? So they tell us in the problem that we're going to let X represent the number of t-shirts. So X is going to be t-shirts. And then they say, and Y is going to be my keychains. Okay? And the total amount of money that they make must equal or exceed the $500. So can we write an inequality? Sure, right? Look on the side, how much are t-shirts? So couldn't we say 10x, 10, however many t-shirts we're going to buy, since X is the number of t-shirts? Okay. And then how much is my keychains? So 2y, 2 times however many keychains we buy, must equal or exceed. So how would we write that inequality? Is it going to be greater than or less than? What do you think? Greater than, right? We want to exceed. So that when we add the total of t-shirts and keychains, we want to exceed $500. So it's going to be greater than or equal to 500. So there's your inequality. But can we graph it like that? No. We need it in what form? Perfect. So we need to get the y by itself. So that's why we're going to solve the inequality for y. So I'm going to just rewrite it down here. And so how do I get the y by itself? What do I first need to do? Rewrite it over here. Yeah, let's subtract the 10x, right? That would be the best thing. So subtract the 10x, and what I do to one side, perfect. And I'm left with 2y is greater than or equal to negative 10x plus 500. I can't combine those. They're not like terms. And then what's my last step to get the y by itself? Perfect. Divide by 2. So y is greater than or equal to negative 5x plus 250. Now I can graph that. So I just wanted to point something out here. This curriculum doesn't give us an example like this, but in case you see it on the LEAP or whatever the case may be, when you divide by a negative or multiply by a negative number, your inequality signs flip. So in this example, if we had divided by a -2, it would have went from greater than or equal to less than or equal to. Okay? Like I said, I don't think my first hour didn't have an issue with the Math Excel, so I don't think there's one like that. But just in case you see that, when I worked all this, I noticed they didn't do that. So if you divide or multiply by a negative, when you're getting it in y equals mx plus b, then you're going to flip the sign. So that would change the shading of your graph, okay? So we can easily graph the y-intercept, but let's label this first. They don't have it labeled, so let's label it. I'm going to do my t-shirts, my x-axis. I'm going to label it by 20s. Just to make it easier, each box is 10, but to write less, I'm just going to do 40, 60, 80, so on. And then your keychains are your Y's. And I'm just, to make it easier on myself, I'm going to do it by 80. So 80, 160. So each block is basically 40. Just to kind of make it easier on us. And this is keychains. Okay, so let's go ahead and graph it. My y-intercept's at what? What's my y-intercept now that we got it y equals mx plus b? 250. Good. So it's going to be somewhere around here. Because we had to go so high on our y-axis, like the number's so large, I could do down 5 to the right 1, but that would take me forever to figure out that point, and it would be too hard. So on Math Excel, the best way to solve this is to make this equation. We take out the y equals negative 5x. We took the same equation. And I remember when I talked about when you're looking for your x-intercept, what was y equal to when you're trying to find the x-intercept? Y must be equal to, anybody remember? You want to find your y-intercept, x is always what? 0. So we want to find the x-intercept, y is always 0. So you would just plug in 0 for your y and solve for x. Otherwise, it wouldn't actually cross the x-axis if y wasn't 0, right? So that's all you're going to do. You're going to take that y equals mx plus b, and you're going to plug in 0 for your y and solve for your x. So whichever one y'all want to do first, we can move the 5x or we can move the 250. Which one do y'all want to do? Okay, so let's subtract 250. And what we do to one side. Good. And so I get negative 250 is equal to negative 5x. And what's my last step to get the x by itself? Perfect. And so this will now give me my x-intercept. So now I don't have to use my slope and find those points perfectly. And like I said, you know Math Excel is tedious. So you want to get your equation or your inequality in y equals mx plus b and look at what the inequality sign is, because that's how you're going to graph it. And then you're just going to want to plug in 0 and solve for x. So x is actually equal to positive 50. So I have an x-intercept at 50. That's going to be the easiest way for y'all. And it's going to make, I think I know you'll get the right answer, but you won't have to go through all this negative 5, down 5 to the right 1, because they don't graph it by ones. They do it kind of like this, by 40s or 80s and 20s. So it's not easy to do. So am I going to have a solid line or a dashed line? A solid line. Good. Remember, it's greater than or equal to. Y'all see that? A solid line. So I'm just going to connect these points and make it a solid. And then looking at my y equals mx plus b, because that's the boundary line, that's what I'm graphing. Do I shade above or below? Above. Good, because it's greater than. So all this area is going to be shaded above. How do y'all feel about that? Yeah, it's not too bad. You make sure you write all this down, because this is what you're going to want to refer to for that Math Excel. It's really not hard. Just getting y'all to remember that x-intercept is when y is equal to 0. Otherwise, it wouldn't cross your x-axis at that point. And y-intercept is when x is 0. You can solve the equation. Okay, and so another little point, just to interpret from this word problem, any point that's in the shaded region or on the boundary line is a solution, and that's because it's what? A solid line. If it were dashed, that wouldn't be it. So any of those points are part of the solution, but here's the crucial part. It's not possible to sell a negative, number of t-shirts or keychains, so you must exclude all the negative values. So if we were to go further down or further to the left, we would exclude the negatives. It would only be the positive numbers because you can't have negative t-shirts or negative keychains, right? Okay. We're going to skip this try it. So we're not doing this try it. So we're going to go to the next example. Can I go to the next one? Everybody got this written down to help you? Okay. So there's 2 typos on here, and this is one of them. Whenever I did the notes, it wouldn't shade. So make sure you shade. It should have been shaded already, but shade above the line for me, please. That should have been shaded already in your notes. So instead of looking at the inequality and drawing the graph, now we want to just look at the graph and can we figure out the inequality? That's kind of what we're doing here. So that little first box on the left, what do you notice about my graph or my shaded region? Is it above or below the line? Okay, good. So shaded above, shaded above my boundary line. That's what goes in that small little box. And then is my boundary line a solid line or a dashed line? Solid line, good. So if it's solid, does that mean we include those values as part of my solutions? Yeah, good. And then that last box, could we write this equation? Could we write the equation of this boundary line? Could we write it? Sure. So I'm going to write boundary line and then put a little colon. What's the equation? What is my y-intercept? Perfect. It's at -3. You can see right here it's at -3. And then what's my slope? How do they get to the next point? Up 1, to the right 1. So my slope is just 1, right? So the equation of this boundary line would just be y is equal to x minus 3. Do y'all agree? Okay, good. So on the LEAP, that could be a very good LEAP question. They could give you a graph like this, and they would want you to write it, the inequality or the boundary line. If we wanted to write this in an inequality, it would be y is greater than or equal to x minus 3, right? This is a very good LEAP question. I could see them looking at that. Okay, we're also going to skip this try it. We're going to go to the next page. Okay, so look at letter A. Now we're going to graph inequalities with one variable in a coordinate plane. So letter A is x is greater than or equal to 3. So before we even graph it, let's ask what kind of line and what area are we shading? So what kind of line am I going to have, solid or dash? Good. And am I going to shade above or below? Above, because it's greater than, right? X is greater than or equal to, so it's above. So remember when we graphed X and Y graphs, remember one was vertical and one was horizontal? So we'll just think about it again. X is greater than or equal to 3. Do I go on the x-axis to 3 or do I go to the y-axis to 3? If I want x is greater than or equal to 3. I go on the x-axis at 3, right? So I'm going to put a point there. If I want all of my x values that are greater than or equal to 3, am I going to want a vertical line here to show those, or am I going to want a horizontal line? Well, if I draw a horizontal, what do you notice? All my lines are now, my x values are every value, right? So what kind of line do I want? I want a vertical line. So now I can shade values that are greater than or equal to 3. And we know it's going to be a solid line. And so which side do I want to shade if I want greater than or equal to 3? Perfect. This is greater than. All these are greater. Do y'all remember x equals is a vertical line, y is equal is a horizontal? Okay, so look at y is less than 2. So what kind of line am I going to have, solid or dash? Good. And am I going to have above or below? Shade above or below, I should say. Below, because it's less than, right? Okay. So if I want y is less than 2, do you think I go to the y-axis at 2 or the x-axis? Good. And I put a little point at 2. And so you could know it's the opposite of the x, but you could also just think about it as on my y-axis, I want every value that's less than 2. Well, my y goes up and down, so I'm going to want to draw a horizontal dashed line because drawing a vertical line gives me all my y values, right? And I don't want that. I want all of them that are less than 2. And so if I was shading less than 2, would I shade above that line or below it? Perfect. Okay, so now they give me a word description, and I'll put this on here because you might see this on the test, but you will probably see this on the LEAP. This is a beautiful question. I think, and you could very well see a question like this on the LEAP. So I just want y'all to see how we would approach this if you saw this on the LEAP. They want me to write the inequality from this description. So in the graph of an inequality, the region above, so we know it's above, shaded above, of a dashed line is a horizontal line. So we know it's above, and it's dashed, and it's horizontal. And this line goes through the point -3 and 2. So what's the inequality? So how could we write this? So we just kind of have to think. A horizontal line, is it going to be x is equal or y is equal? Y. So we know it's going to be y. And if it's above and it's dashed, what kind of inequality are we going to have? Greater than, but no equal to, right? Because it's not solid. So it's going to be y is greater than. And then we know it passes through this point -3, 2. Well, what is my y value in that point? 2. So that has to be the line. Y has to be greater than 2. Y'all see that? That's it. That's the inequality for that one. So I just want you to be able to understand, like we can look at the graph, write the inequality. They could give me it in words, right? If you get really, really confused though, draw it, right? Like draw the line. Draw a horizontal line at 2, but it should have been dashed, so I didn't do that right. Ooh. You could draw a horizontal line at 2, and it's above shaded, so you know it's got to be greater than. So all this is shaded, so we know it's got to be greater than, right? And we could easily see that. Some of my visual learners do better with that. Okay. Any questions about those? Okay. Number 5 has a typo, y'all. On that second inequality, it should be a -x. See, so I have it highlighted up there. Make sure it's a -x when y'all's in. Sorry about that. So it should be y is greater than x minus 2, and then the second one should be y is less than or equal to -x plus 1. So up to this point, we've graphed one inequality. Now we're going to do what happens when we graph 2 inequalities. Okay? So we're going to treat it just like we did the other ones. We're going to graph the first inequality, then we're going to graph the second one. So let's graph that first one. But before we do it, am I going to have a solid or dashed line for the first inequality? A dash. Good. It's no equal to. I'm going to use a different color. And am I going to have shade above or below? Good. So dashed, and it's going to be above. So where's my y-intercept with that first inequality? Good. So I'm going to go on the y-axis to -2. And what's my slope? 1 over 1. So I go up 1 to the right 1 and so on, right? It's just to kind of help me plot my points. And I know it's going to be dashed, so I'm going to go ahead and draw a dashed line. And we said it's going to be shaded above, so all of this area gets shaded. So let's look at the second one. What kind of line am I going to have, solid or dash? Solid, good, because it's equal to. And then am I going to shade above or below? Good, because it's less than. And so what's my y-intercept of that second inequality? 1. And then, can y'all see that red dot? Kind of, sort of. And then I'm going to go, what's my slope? -1. So I go down 1 to the right 1 and so on, right? Okay. So it's going to be a solid line. And if I'm going to shade everything that's below, what do you notice? They overlap at some points, huh? You don't see a difference? This was all purple. Like this whole area was purple, and then we shaded the yellow, which is my second inequality, and now this red part is where they overlap. I just did that so you could see a different color. So when you're doing solutions of linear inequalities, the solutions are the shaded area where the regions overlap. So both of these inequalities would be true only in that red section of my graph. If it were just the purple section and the red section, that's for the first inequality. If it was just the yellow and the red, that's where it's true for the second inequality. But where we're trying to find where they both are true statements is only that red section. Does that make sense? Where they overlap. So in like Math Excel, when you graph it and they want you to graph two inequalities like this, you're gonna be able to like use a little painter tool to dump paint and it shades it. That is you're only going to want to shade when you're doing the inequalities, two of them. You want to do the shaded region where they overlap. You don't want to shade all the regions where you would technically shade on the graph. You only want to do where they overlap. So if this was a Math Excel, we would only shade that red part. So points on a solid boundary line are only solutions of the system only when they are also in the shaded region of the other inequality. So like, for example, this part right here, that part would be included because it's a solid line and it's in that shaded region. But this other blue line, the other blue line down here would not be part of my solution. So y is greater than or equal to -x plus 2. So am I going to have a solid line or a dashed line? Good. And am I going to shade above or below? Perfect. So let's graph it. What's my y-intercept of that one? Awesome. And then what's my slope? Down 1 to the right 1. And you could keep going on and on and on, right? But I just did that to help me get my line. So I'm going to draw a solid line. And I'm shading above. So all of this area.
Are we ever going to have like one where it doesn't overlap?
And then what's the second inequality? Is it going to be a solid or dashed line? Am I going to shade above or below? Good, because it's less than. And so what's my y-intercept of that one? Perfect. My slope's what? Down 1, right 1, down 1, right 1, so on. So it's going to look like this. And if I shade below, what do you notice? What do you notice? They don't. Yeah, they don't touch. They don't ever overlap. So what do you think? Are there any solutions that make these true? Nope. So this is no solution. Because the regions don't overlap. Okay, so that's it for today. You'll have 2 Math Excels. Let me add a little tab. They're 4-4 and 4-5. I think this one's 9 questions. And I want to say this one's 5. And remember, they're going to be due tomorrow at 10 p.m. But y'all should have plenty of time to finish them today.